there. If you're watching this video, then it's probably because you didn't like your grade on this last section that involves symmetry. So this is lesson 1E. And like the other sections, if you want to retake this, you will need to correct your test. You'll also need to do the homework. And if you want this to replace your quiz grade, oh wait, there wasn't a quiz for this section, so never mind. But if there was, you would have to correct that as well. Okay, and maybe some other stuff, whatever I decide. Look on Google Classroom. So we want to test each of these equations for all 4 types of symmetry. So that means we're going to have 4 answers here. We should say yes or no 4 times. 4 answers here. Does it have y-axis symmetry? Yes. Does it have x-axis symmetry? No. Etc. etc. The same on this one. So on number 16, does it have y-axis symmetry? So there's not a lot of room here. I'll see what I can do. Y-axis symmetry, you replace x with negative x. So that's negative x equals 4 over y. Is that going to be the same as the original? No, because the sign is changed on one side but not the other. X-axis, we're going to replace y with negative y. So that's x equals 4 over negative y. Is that going to be the same? No, for the same reason. The sign on one side is changed but not on the other side. So it is a different equation. Origin symmetry. Is this an odd function? Let's see. So for origin symmetry, remember that's 2 different folds. So the x becomes negative x, and the y becomes negative y. So we change both the x and the y to a negative. Is that the same as the original equation? Now it doesn't look the same, but because both sides have become negative, we can multiply through by a negative, and that would give us exactly what we have as the original equation. So it doesn't look the same as it is, but with one simple step of algebra, multiply through by negative 1, it would match the original. So yes, it's equivalent. It doesn't have to look the same, it just has to work for the same x and y values. And then for y equals x, or line symmetry. Here we would just switch the x and the y. So we would have y equals 4 over x. Is this the same? Well, it might not look like it, but notice if we multiplied both sides by x, so if we try to make it look like the original, multiply both sides by x, okay? And now to get the x by itself like it is in the original, I'm going to divide both sides by y. And I would get x equals 4 over y. So yes, it's just a rearrangement of the original equation, so it is equivalent. So this has both. And again, to test it, we could solve it for y and type it in your calculator. We looked at an example like this in the review, and it has just those 2. So on all these questions, you should have 4 answers. No, no, yes, yes. For this one, for y-axis symmetry, I'm going to say y equals 3, and then everywhere there's an x, I'm going to replace it with a negative x. Minus negative x squared, sorry, that's something from a different problem, plus 7. So, would this be the same as the original? Yes, because here the negative, because it's raised to an even power, would go away. So negative x to the 4th is the same as positive x. The negative would cancel. Same here. Negative x squared is the same as positive x squared. So yes, it is the same. For x-axis symmetry, that would be negative y equals 3, and then the x's are going to stay the same. Is that the same? No. And so, no, no. So this one has none of those. So make the same replacements. There's no way you can rearrange any of these bottom 3 to match the original. And so this would be fine as an answer, or you could say it just has y-axis. And on this one you might say it has odd symmetry and line symmetry. Or in other words, origin symmetry and y equals x symmetry. Or just a list of no's and yeses if they're labeled. That's fine as well. So here we're going to do the same. The y-axis symmetry, I would make x negative, negative x squared, plus y squared equals 16. And so essentially what you want to know, would that negative cancel out? Yes, it would. So it matched the original. So yes. For x-axis symmetry, that would be folding the top one to the bottom. Positive y's become negative y's. So x squared plus negative y squared equals 16. And by the same logic, that negative would cancel out. So yes, that would match the original equation. For origin symmetry, I change both the x's and the y's to negatives. Would that match the original? Yes. Both of those negatives would cancel out, and you get the original equation. So yes. Remember, anytime you raise a negative anything to an even power, the negative is going to cancel out, because you've got two negatives multiplied together, or even if it was four negatives multiplied together. Now, what about y equals x symmetry? That would give us y squared plus x squared. So here we switch the x's and y's. We just swap where they are. Y squared plus x squared equals 16. Is that the same thing? Now, it's written in a different order, but when you're adding, remember, you can just switch the order. That's the commutative property. So yes, it's the same as the original. Yes. Okay. So this one has all three. All four, sorry. Okay. On number 19, we want to sketch a picture or a graph or something that exhibits either y equals x symmetry or odd symmetry. And then tell me which one you were going for. That way I can grade it. So, let's see. Y equals x symmetry is pretty easy. So basically I just need to make this a reflection of that. And that's it. So one easy way to make this happen is I might draw something on one side, and then I'm going to reflect it onto the other side. More or less. Okay, so I drew a fish. So this fish has y equals x symmetry. It's symmetric across the line y equals x. If I wanted to draw something with origin symmetry, I could even use a graph. And even if you remember a graph that has origin symmetry, like x cubed, something like that, maybe you could remember that this has origin symmetry because origin symmetry is also known as odd, and it's got an odd exponent on the x. So there's origin symmetry. Something like that. And another way you can think about origin symmetry, it's rotational symmetry. So if you rotated the function 180 degrees, would it still match the original? Like that. That was a terrible picture, but if we rotated 180 degrees, it would look pretty much the same. At least I was trying to make it look like that. Okay. So that is symmetry. So you need to check each one for all four. And again, if you're struggling, come talk to me. I'm here every day, before and after school, at around 8:15 and until about 5. So come find me.